When we're asked to integrate this expression, we're being asked to find the indefinite integral of 3x squared plus 2x plus 1. To do that, we just take it term by term. So we're going to look at this 3x squared and use that power rule that we developed. And that's that we're going to increase the power by 1 and then take the coefficient that's out in front and divide by that new power. So when it comes to 2x, increase the power of x by 1, so now it's up to 2, and take the coefficient divided by 2. For any constant term, right now the power of x is actually x to the 0 power, so I'm going to increase that to x to the first power, take my coefficient and divide it by the new power. The last thing that we're always going to have to remember is to add the constant. Whenever we're taking the indefinite integral, we have to have a constant on the end. So cleaning this up, we end up with x cubed plus x squared plus x plus that constant c. When it comes to the trig functions, be very deliberate and think about this in terms of an antiderivative. That when I'm trying to integrate the sine of x, I'm looking for a function whose derivative is sine. Now, we remember that sine and cosine are related to each other, and so we're thinking that the integral of sine is going to be cosine. Check that, all right? If the integral of sine is cosine, then the derivative of cosine is going to be sine. Is the derivative of cosine sine? No, it's negative sine. So that means we need to include this negative in front of our cosine. Now when we move on to cosine, the derivative of, or the integral of cosine, we think is sine. So check it. Is the derivative of sine cosine? Yes, it is. So we're good. And the last thing that we always remember is our constant of integration. In this third one, we have e's and fractions. The thing to remember about e is the integral of e, just like the derivative of e to the x is e to the x, the integral of e to the x is e to the x. For the fraction 1 over x, if you think about this as being x to the negative first power, and you try to use the power rule on it, then you're looking at increasing the power by 1, so up to 0, and taking the coefficient and dividing it by 0. And that's not anything that we can do. Dividing by 0, definitely not cool. So let's go back and think about that 1 over x again. What function has a derivative that is 1 over x? And that's going to be the natural log of x. Once we have our two terms, always include that constant of integration, and there is our integral. For this integral, the function is a lot more complicated. It might be a little bit easier to rewrite the integral as x to the fifth plus x to the negative second power and plus x to the 1/2 power. Now that we have each term written in terms of powers, we can use that power rule. So for x to the fifth, I'm going to take the power and increase it by 1, then divide its coefficient by the new power. On the next term, increase the power by 1, so now it's up to -1, and divide the coefficient by the new power. And for the last term, increase the 1/2 by 1 up to 3/2, and take the coefficient divided by the new power, always including the plus c at the end. Now we can finish up our integral just by cleaning up the expression. 1/6 x to the 6th power plus -1, so that's going to mean -1 x to the -1, so that's 1 over x. And then plus 1 over 3/2 is the same as 2/3 x to the 3/2 power plus c. And we're good. The last two I put right next to each other to illustrate that importance of the dx or the dw in these two cases. That differential actually tells us which variable we're integrating with respect to. So really, this integral is the integral of 1 with respect to x. So when I integrate this, I know which variable to use. the variable is going to be x, and of course including c as our constant of integration. When it's the integral of dw, that's the integral of 1 with respect to w. So the variable that we would use is w, always including our integral, our constant of integration.